what all these things are. So capabilities and ownership, of course, are right in the IWACO acronym, so they're near and dear to the heart of what everyone's here for. But I've also thrown in this mix of behaviors and effects, and because I think they are all related to each other. They're all sort of different sides of the same coin, a many-sided coin, as you would. Because capabilities are fundamentally a tool to restrict side effects, right? The idea is that a capability is a permission to do something, and then if we don't give that permission to some part of the system, then that part of the system can't do the thing, right? So there's this negative implication when we don't provide a capability. But then there's also this notion of ownership, right? Which has morphed a little bit in the last decade, but in the classic view is keeping track of which objects own other objects, with an idea towards sort of keeping track of who's allowed to muck with the representation of a particular object if it's composed of smaller objects. So the owner might, for example, be allowed to modify its representation, but other parts of the program, if they get a reference, would only be able to observe the internals of some other object. And this, of course, is intertwined with uniqueness, which I think we're going to hear about in some other talks today. I'm not going to get into that in my talk. And then there's these effect system things, right? Effect systems like Java's checked exceptions, or keeping track of region accesses and region-based memory management. And so that's another tool in our bag of tricks to reason about and restrict side effects. And so if you're not confused yet, I think probably all of us should be confused, because these are all trying to solve kind of the same problem in philosophically very different ways, right? And so what I'm going to talk about today is, many of us have kind of had these three things kind of bouncing around in our head for many years. But what happens if we throw behaviors over time into the mix? And how does this affect what the relationship between these things look like? And does it actually help us shed some light on the relationship between these things? Now, to sort of set the stage and what my sort of mental starting point is, if I were to make a slide for the express purpose of antagonizing Tobias and James and Sophia and other people in the community, I might make exactly this slide. So, we have, of course, the pool. Oh, all right. Well, now I know how to play to you. All right, so we have static reasoning systems, and there are a whole lot of them. And of course, most of them are type systems, but don't tell the SAS people down the hall, okay? And within the space of type systems, we have static capability systems, right? So there are many people who have built static capability systems who might not think of them as type systems, but you can move the pieces around and you can recast them pretty much universally as a type system. And then within that, there's, of course, static ownership systems in practice. Now, there are some things that blur the lines a little bit there, like some of the spec sharp work and things like that, but we're going to ignore that for now, right? So this is almost true, right? At the same time, we have this other big orange box over here of effect systems, right? This other big category of type systems for reasoning about side effects. And a lot of us over the years have kind of poked and prodded at different aspects of how are these two orange boxes related to each other, right? What's the relationship between them? But we haven't spent as much time thinking about what exactly happens in the course of that relationship between these ownership systems when you start to look at them from the effect side. And there's also this interesting bucket of effect systems over there, sequential effect systems that deal with behaviors over time. And we haven't really paid much attention to what happens when you try to push those back onto the capability side of this view of things. And so pondering these kinds of issues is basically how I ended up spending 8 years just working on effect systems instead of capability systems. Because I had this great idea that, hey, there must be this relationship between these flow-sensitive effect systems and viewpoint adaptation in ownership type systems. And if you don't know what viewpoint adaptation is, that's okay. It's a detail that shows up in some systems where if you follow a sequence of steps through the heap, this affects the type of the thing you observe. And I had this great idea exactly 8 years ago. And I thought, oh, I'll be done in a couple months. Well, a lot of the stuff that I assumed had been worked out in detail, turns out, had not been worked out in detail, even though a good amount of it was kind of in the air. So if you look at, what's the basic relationship ignore behaviors over time. Just think about these, can you or can you not do these things? That relationship actually wasn't written down until a couple years later by some of the Wyvern folks. And if you look at just the basics for flow-sensitive effect systems, if you wanted just the bare bones, there were some solid foundations there, but there were a lot of gaps between that and practice. And so I spent 8 years sort of figuring out what are all these gaps and filling them in. Because if you wanted to do loops, there was some nice stuff from Mycroft, Orchard, and Petracek that was a little overly narrow, didn't capture some systems people had actually built. So I tried to generalize that. And it turns out the first time I tried to generalize it, I didn't quite do it right. I didn't quite finish the job, so I had to go back and do some more generalization. And then, of course, if you sit down to try to implement these things for a real language like Java, you have exceptions, you have early returns, you have breaks. And so I thought, well, rather than working this out for 15 variations on a theme, I'm going to work this out for all of tagged delimited continuations, and that's a great idea. And that was a painful idea, and I don't recommend it, and I'm going to blame that on Sriram Krishnamurthy for teaching me that continuations were a good idea. And then if you look at, okay, great, so now we have all this, and the errors that come out of an implementation for this are terrible, so we need some work on error reporting, right? And so I had to go fill that in, right? And so now at this point, I've spent 8 years just working on effect systems, not actually connecting them back to capabilities, right? So let's go back to that and let's revisit this relationship between capabilities and effects, right? With all these new kinds of toolkits behind us. So if we think about what really is the essence of a static capability system, what is it really doing differently from an effect system? There are a lot of answers, right? And if you ask a number of people in this room, you'll get slightly different flavors on a theme. So I tried to write down at least my take on this a few years ago. And again, a lot of this was kind of in the air. Many people had kind of intuitions on this. This is one of those things where I could easily see James jotting this down on a pub napkin 20 years ago and not sharing it with anyone. So there's a lot of stuff in there. It's kind of a discursive philosophical write-up of sorts. But the two things that are relevant here are this classic idea of, well, capabilities intuitively are supposed to bound static effects. And a new idea that sort of relates effects and capability systems by drawing on this use-mention distinction that comes out of philosophy of language. So the basic idea, which I'm calling capability bounding here, is this idea that the set of static capabilities you need to check something in a static capability system basically corresponds to a fixed over-approximation in a static type and effect system, right? And again, this is an old idea, but one that kind of wasn't really formalized super explicitly for a long time, right? If you go look at like most of the early attempts to talk about effect systems as sort of abstract, general, like an effect could be anything kind of things, what they do in practice is they formalize dynamic capabilities, and then the static effects classify which capabilities actually get used at runtime. And so that's baked in there pretty sort of naturally. But this wasn't really made explicit until some stuff coming out of the Wyvern group around 2018, right? And so if I kind of riff, this is not exactly how the Wyvern folks framed it, but if I'm going to frame it my way, the idea is that for any static capability system, there exists a function from the capabilities you use to check the program into a space of effects for a corresponding type and effect system. And if you follow this function, then if you know that a term is valid with a certain set of capabilities, then you know it has an effect corresponding to this mapping into the effect space, which is going to be an over-approximation of what actually happens, right? A sound approximation. And this is cool, and this is useful, and it's also a little bit imprecise, right? So it forms a trade-off, right? So I tried to draw this out with this use-mention distinction, and this is an idea that comes out of analytic philosophy, philosophy of language, and deals with when you're sort of having meta-level discussions about abstract concepts, right? It has to deal with quotes and reports. So if James goes later and tells Sophia that I said all ownership systems are type systems, he's not necessarily endorsing that idea. He's referencing, mentioning that idea, but not necessarily invoking the concept himself. A more grounded example might be, we can talk about this word cheesecake in English as a compound noun, where cheese is a prenominal modifier of cake, and this is just a mention. We're not really talking about the underlying concept of cheesecake, we're just mentioning cheesecake, which is different from using the concept by talking about how, especially after weeks of practicing this talk, I really, really, really want cheesecake right now, right? This could well be that. I sadly had to miss Mark's talk, but I'll have to watch it on the recording because I've heard a couple people say it was very good. So I'll get back to you on that. So this concept, this distinction between use and mention, turns out, I think, to be a useful articulation of the trade-offs between most capability systems, static capability systems, and most effect systems. So if you have a capability judgment, and here I've separated the capabilities from any normal types just for clarity. If we have a capabilities judgment like this, where we have a set of capabilities that are needed to type check the program, this is sort of implicitly treating it as, well, if we want to reason about what E might do, this is assuming anything that might be mentioned might be used, right? It might be that this capability kind of flows through and doesn't actually get used for anything, but it's there, so it looks like worst case, maybe it does get used, which is sound, but imprecise, versus effect systems, which really try very hard to split the difference and say, this is what actually happens during execution versus what could happen during execution, right? Yes. Oh, yes, I don't mean to suggest that these are perfectly precise, but the sources of approximation are different, right? And the gap from dynamic behavior is different, right? So this is a trade-off, right? Because this capability bounding type of use, you want me to use this one? So, all right, the capability bounding type of use, doesn't require you to inspect the internals of the expression. You see what goes in, and you can reason coarsely about what happens internally. And this is useful for safe concurrency. It's used for all sorts of things, for the same reason that the dynamic version of this, going back through Mark's thesis and back into earlier stuff than that, is useful, right? It's a very coarse approximation. So he asked, does this have anything to do with the difference between effects and co-effects? And sort of. So I'm going to punt that to the end or offline because it gets subtle. So capability bounding conflates use and mention, right? So if we have this tiny example here, let's have a capability safe print function. If we give it the I/O capability, but we never fully apply it, we never actually cause the printing to occur, then we need that capability to check this code, but we never actually cause that behavior to happen, right? And so if we take the capability bounding effect that says, oh, well, we give it the I/O capability, therefore maybe I/O happens, right? So it's over-approximate. But even a small effect system can make this distinction where we say, hey, if we give this capsafe printf a type that says, the first argument, supplying the capability, doesn't trigger any effect. It has a latent effect that is unit. And it's only the second application, after we give it the thing to print, that actually triggers the I/O to happen. This actually makes this distinction. So this type, where we partially apply it but don't actually print anything, gets a unit effect, right? And this is something that shows up throughout the literature, right? So for many people, the first thing that anyone read that I wrote had this rule in it for safe concurrency, where we say basically these type environments are sort of input-output type environments for threads we're trying to parallelize. And this first assumption here says, as long as no thread has a writable capability, this is safe to parallelize. We can't cause a data race because no one has the capability to cause a write that would trigger a data race. But this is imprecise, Because what if there was a writable reference in one of these contexts we wanted to parallelize, but we don't actually dereference it, right? Versus a very, very simple effect system can make that distinction, right? So we can give, if we just have a local variable assignment, we can give that the pure effect because we know it's not actually using the capability to access the heap, versus if we do actually use the capability to access the heap, we can give it an effect that indicates that, right? So this is kind of where things left off with that Perl, and now let's revisit this notion of behaviors, right? So let's go back to this question of what is an effect, what is a behavior, and what do capabilities allow or disallow, right? And so historically, for most static capability systems, most effect systems, they're focused on this question of we do or do not do certain things, right? We do or do not use this resource, or we use or do not use this subset of resources or perform this subset of actions. But if we start thinking about orderings, if we think about using a capability over time, right, using it multiple times, if we start thinking about multiple capabilities that might be entangled, right, related to each other in certain ways, and we'll give some examples shortly, how does this start to change the relationship between capabilities and effects if we start trying to relate capability systems and effect systems that are dealing with these behaviors over time? So to be concrete, we care about things like if you acquire locks in some orders, you might avoid deadlock, and if you don't follow those restrictions, you might deadlock or violate atomicity. If you have multiple pieces of state, updating the components in a particular order might preserve some invariant continuously throughout, versus if you update in a different order, you might temporarily violate an invariant. This might complicate some reasoning. And there are cases of linked capabilities, like certainly if one capability is used to create or destroy another capability, let alone cases where you have capabilities to an aggregate or to a piece of an aggregate. This shows up in a couple different variants in Rust with reborrows and nested borrows and borrows to fields of objects. So, okay, surely after 8 years of staring at the effect system side of this, surely I have all the answers for the capability side, right? We're getting there, right? So here's where we are. So right now I have two systems. One's a flow-sensitive static capability system. One's a sequential effect system, where the effects are behaviors over time. They're in fact basically program traces. And they're related. There's a junction between them where the capability system upper bounds the effects, and the effect system lower bounds the capability system. And here's what this ends up looking like, right? So if we do flow-sensitive effects the way I've been doing them, and if you're familiar with things like graded monads, you'll see some differences and some similarities here that we could talk about offline. We have a set of behaviors, because of course we care about the behaviors. We have a least upper bound. Maybe we have a then branch and an else branch. We don't know which one we are going to run. And there's a sequential composition operator for cases where we do know we're going to do this operation and then next this operation, so we know the program ordering. And then we have a unit for sequencing, and there's a whole bunch of complicated laws that these satisfy that we won't get into. But the upshot is that we get to write rules like this, where if we have two expressions that we run one right after another, and we want to think, what is the effect of running one right after the other? Well, it's the effect of the first sequenced with the effect of the second, which is kind of what we set this up to make easy to state. So what's the capability system look like? Well, there are actually a lot of capability systems that already have this shape, where we have basically input and output capabilities, right? So we have an initial set of capabilities, kappa. We run the program, and then we finish with some residual leftover capabilities, kappa prime. And this actually starts to capture some of the use, the details of what does and doesn't happen with the capabilities, which didn't happen in the classic case. So we can see signs here of creating new capabilities, destroying or consuming certain capabilities, or updating them. And the sequential composition here is also not super surprising, right? We have some inputs here. Input capabilities, output capabilities, those feed into the second expression. But if you kind of rearrange the deck chairs here, it turns out, if you just look at those pairs of capabilities, they satisfy the laws for an effect quantale. And so I would argue that this is, even though I tried really hard to make a capability system, it's actually an effect system in disguise, right? But it's not truly an effect system in its full generality, right? So if we have these pairs of input and output capabilities, we can talk about capability bounding, but it looks different than it used to, right? So in particular, we can still say, we didn't give you this capability, so you can't do this thing at all. But we can also say, hey, we can see that you kind of used this capability, right? Or you consumed this capability by looking at the difference between the input and output capabilities. And this is part of what I was arguing was sort of characteristic previously of being an effect system, is seeing those aspects of use. Instead, we're approximating something else, right? And what we're approximating is we don't know what order we used these capabilities in. We don't know if we used A and then B or B and then A. We just know that some interleaving of the things we can see individually being used did occur, right? So there's still an approximation that's happening here. And I think this is interesting because it gives us sort of a foothold on thinking about what behavioral notion of ownership might look like. So specifically, if we're thinking about behaviors in an ownership system that are more nuanced than read versus write, classic ownership is about who in the program, who being what objects, get read or write access to representations. But with behavioral ownership, we can start to think about who gets what kinds of usage permissions to different parts of the representation while still respecting what the owner states as, here's how my representation should be used. And this has connections to some stuff that a number of people have worked on over the years. This idea that if we're going to take a capability and share it or split it or reuse it, that basically we have to preserve sort of the sum total of what capabilities might exist in the system. And it turns out we start getting into a little bit of the weeds here. So I had an asterisk a couple slides ago when I said that we saw usage. But we get some cases like this. So in the system I'm doing right now, we can have an input that says, well, this file could be read or written a number of times and then closed. And the output says it could be read or written a number of times and then closed. But this doesn't actually tell us whether any reads or writes actually occurred, right? So there's some language theoretic tricks we can play to say, well, what might have happened was some number of reads and writes, but certainly not a close. But this is important because this kind of cyclic capability is one we can use in a pattern repeatedly over and over again. And this is important for cases where we store a capability in a data structure. We usually don't want the field type of a data structure to change line to line of the program. So having some fixed cyclic capability where we can keep peeling off, a limited use capability every time we need one is a very useful thing to be able to do, and it fits sort of naturally into this framework. But even this is still just a capability system because a lot of what ownership is about distinguishing the owner's rights to an object from the rest of a program's rights to an object. But this opens the door to some interesting things, right? So there are natural analogs of owner as dominator, owner as modifier, right? You can refuse external references entirely and just get stronger reasoning within an ownership domain. You can force unowned references to be pure, but now there's a little more nuance because you can say, what kind of pure, right? Or what things are you allowed to observe versus what things are you not allowed to observe? And we also get sort of other interesting, different things that don't have a natural analog in previous ownership literature, right? So owner for critical operations, right? If we have that file object, as long as the owner is able to close it, you kind of don't care if some other part of the program maybe gets to read from fixed offsets, and then if the owner decides to close the file before some other part of the program was ready, that's fine. The owner's integrity is preserved, right? Just like if in classic owner as modifier, if you set a field to null as the owner, if somebody else crashes, that's their problem. Or you could have notions of owner for some aspects, right? You have an owner that's in charge of certain aspects of using an object, but somebody else is in charge of other aspects of that, and that's actually shown up in a lot of work like some of Elias and Tobias's work a number of years ago. And surely there are more here, right? So this is a much richer space of what can you or can't you do, how can you use things. So to wrap up quickly, I think this is really interesting because in addition to giving us power, this sort of blurs the line, or at least makes the line between capability systems and effect systems a lot more nuanced, a lot more interesting. Because the flow-sensitive ones capture more nuanced than do you or don't you do this. It opens the door to new kinds of ownership, and especially for the more junior people in the room, it may turn out that things you assume are set in stone and fixed and everybody's figured them out, you may be one poorly conceived question away from your own 8-year odyssey in a different research area. So, which was unexpected but fun. Thank you.